section 4.2, we're going to talk about logarithmic functions. And I want to recall that a function has an inverse if it passes the horizontal line test. So remember, our exponential functions look like this. And it only passes through 0, 1. I'm going to draw a better one. Pass through 0, 1. And we have an asymptote right here. So this passes the horizontal line test. So if you do the horizontal line test, it'll just 1 point. So an exponential function has an inverse. Okay. So what's one easy way to graph an inverse? We go back to the last chapter. All we did was switch x and y. Okay. So that's what we did before. That's an easy way to graph an inverse. But how do you find the inverse algebraically? So let's go back to the exponential function, which is f of x equal b to the x. And remember the fourth step that we followed? We said well, that's the same thing as y equal b to the x. And then we switch x and y, so x equals b times, or b to the y power. And following the four steps listed back in chapter, I believe it was 3.5, we talk about inverses, 3.5, or maybe it's 3.4, whatever it was switch, we went y equals, then you switch x and y, and then now we're going to solve for y. The problem here is I want to solve for y. It's not as easy as what we did before. How do I solve for y here? Well, there's no way to undo that exponent there. So we need to know how to do that. Well, we have something called logarithmic, so we need to solve for y. Something called logarithmic notation. So to isolate exponent y, we use logarithmic notation. Okay. So let's go ahead and talk what that means. Okay. The inverse function of the exponential function with base b is called the logarithmic function. Y equals log base bx. And when you write this out, I'm going to write this out very carefully. Write that one more time. You're going to have y equals log, and this b is a subscript, so b, and then the x on the same line as the log, is equivalent to b to the y equals x. Okay. So I'm going to we're going to look at this carefully in the next example, but this is what we're going to have to memorize and know for the exam right here. Okay. So let's look at example 1. I'll leave this up here, right there on the top of the screen. You can still see that right here. Write each equation in its equivalent exponential form. Exponential form is this right here. This is logarithmic form, and exponential form is right here. So this is logarithmic form. This is exponential form. Okay. So if you see this right here, this right here is your base. The subscript here is your base. This number out here, that's what it's equal to, is your exponent. And this is what it's all equal to. So this is your base. So 5 to the second power. Okay, this is your base. This is your exponent. It's going to equal x. This is the equivalent exponential form. This is your base, so b is your base. 3 is your exponent, and it's going to equal 64. 3 is your base. Y is your exponent, and it's going to equal Okay, so you gotta remember how to undo that. So this is your base, this is your exponent. So here's your base, well, there's the base, y is your exponent, and it's going to equal this number right here. Okay, so go ahead and pause the video. It's really important that you're able to switch from logarithmic form to exponential form. Very important in this chapter, so get comfortable with this. Pause the video and go ahead and try this on your own and see if you can do it. Okay, so for part A, this is your base, this is your exponent, it's going to equal x. Base is b, exponent is 2, it's going to equal 25. Base is 4, exponent is y, there it is, and then equal 26. Okay. Now can we go backwards? If we are given the exponential form, which is right, these are all exponential form, can you go and give the logarithmic form? So we're going to go ahead and write that out. So we have log, and the base in this case is 12, that goes down here in the subscript. And the exponent is 2, so it's going to equal 2, and then the x is going to be right here. Okay. For b, it's going to be log, and the base is b. The exponent is 3, so it's going to all equal 3, and a goes right here. And in c, I have log, and the base is e, and my exponent is y, so it's going to equal y. And I get the 9 right here. Okay, so on your own, go ahead and try the next 3 and see if you can go back to logarithmic form. Again, it's very important that you know how to do this as we move through this chapter. Okay, so go ahead and pause your video. Okay, so here are the answers for part A, B, and C. Okay, so let's go ahead and do example 3. Now we're going to evaluate. Remember, evaluate means to find a value. So evaluate log base 2, 16, okay? So we got to figure out log base 2, and it's going to equal 16. We got to figure out what goes right here. What exponent can I use? Okay. Another way to look at this, and actually probably a better way to look at it, is to look at the base is 2. So actually, I forget what I just said a second ago. The base is 2. I'm going to figure out what exponent do I need to get 16. So the answer would be 4. Because 2 to the base to the 4th power equals 16. Okay. The next one, we have 7 to the base. We're trying to figure out what exponent will give me 1 over 49. Okay. Now think about this very carefully. What exponent will give you 1 over 49? Well, remember, we can use negative exponents. 7 to the negative 2 is equal to 1 over 7 squared, which is equal to 1 over 49. So it looks like if I had a negative 2 as my exponent, that would be the 1 over 49. So that one you have to think a little more carefully about. 7 to what power gives me 1 over 49? Well, 7 to the negative 2 will give me 1 over 7 squared, which is 1 over 49. Okay, the next one I have 25 to what exponent will give me 5? You know, I think careful with this one. We go back to the P chapter here, and we're going to do a fractional exponent here. So if I have 25 to the 1/2, that's going to equal the square root of 25. Remember, this is the index, so the square root, which is this 2 right here, and then 1 power will be out here. Well, square root of 25 is 5. So it looks like if I put 1/2 right here, I'll get 5 back out. This is going to equal 1/2. Okay, and then the next one, part D, 2 to what exponent will give me the 5th root of 2, and that would be 1/5. Okay, so because 2 to the 1/5 equals the 5th root of 2 to the 1st power, which is equal to the 5th root of 2. That would be 1/5. So on your own, go ahead and try the next 4 and figure out what the value is for these. Pause the video, please. Okay, so for the first one is 2 because 10 to the 2nd power will give you 100. This is going to equal 2. Part B, 5 to the negative 3 power will give you 1 over 25 because 5 to the 3rd negative 3 power equal 1 over 5 cubed, which is equal to 1 over 125. The next one 36 to the 1/2 power will give you 6. And the last one, I didn't do this one because I forgot to put the little square root sign there, or the radical sign. This should be this. Go ahead and fix that in your notes. And again, if you have a new addition, it might fix that for you. Okay. You should have 1/7 because 3 to the 1/7 power equals the 7th root of 3. Okay. Example 4. Let's go ahead and evaluate these. We're going to do the same idea. 7 to what power will give me 7 right back? That's going to be just 1. 5 to what power will give you 1 back? That's going to be 0 because 5 to 0 equals 1. Okay. On your own, go ahead and try these two. And I'll pause the video while you pause yours. Okay, first one, it should be 1 because 9 to the first power is 9. And the second one should be 0 because 8 to the 0 power is 1. Okay. Now that we're familiar with logarithm notation, let's go ahead and finish the switch and solve strategy for finding the inverse of f of x equals b to the y, or b to x. Okay, f of x equals b to the x. And again, we're going to write y equals b to the x. And then we're going to undo, we're going to solve for, we're going to switch x and y so I get x equals b to the y. Okay, so now we're going to solve for y. So to undo this exponential, exponent, we're going to go ahead and write log, the base is b, the exponent is y, so it's going to equal y, and then you have x here. I get y equals log base bx, and the inverse function is going to be f of -1. That's the notation we used in the last chapter. Of x equals log base bx. Okay, and this is the inverse of the exponential function f of x equals b to the x. The inverse properties. So let's go ahead and look at these inverse properties, and basically we're just undoing things. So in example 5, I have log base 4, and this is 4 to the 5th equals what? So what exponent, 4 to what exponent will give me 4 to the 5th back? And that's just going to be 5. This log base 4, and then we have base 4 again. That just pretty much negates each other out. It's kind of like the inverse with 4 top 4. And if you don't remember that, you just look and see, well, what exponent do I need on the 4 to make this 4 to the 5th? Well, you need a 5. Okay. Here I have log base 6, 9, and these base 6 here, it's going to cancel each other out, and you're going to get 9 there. We're going to see that a lot of times, so keep that in mind. Okay, on your own, go ahead and do these two on your own, and I'll pause the video while you do that. Okay, you should get 8 and 17. Again, this base are the same, this base are the same. They're going to negate each other out. Okay, so the next thing we're going to talk about is the graph of logarithmic functions. And so remember, the exponential function and logarithm function, those are inverses of each other. So we should be able to do the switch the x and y strategy that we've done before. I'm getting close to my end of my 15 minutes, so I'm going to go ahead and just stop the video here, and then we'll do this graph of logarithm functions in the next part.